All right, guys, welcome to 6.6. This is the last section in the chapter. This is where we also incorporate the phase shifts, which are the horizontal shifts. And those get a little bit tricky. Okay, and here's why. When you're graphing sine, cosine, tangent, cotangent, secant, cosecant, if there's ever a number in front of the x, you need to factor it out so you can really see what the phase shift is. For example, a lot of people might look at this and say, oh, the phase shift is right pi. That is not right. So what you need to do first is rewrite it. So y equals 3 sine. You need to pull a 2 out first. And if you divide it out, what's inside that parenthesis becomes the phase shift. So if you divide x by 2, you get x minus, but now you have to divide pi by 2. And then you get pi over 2. This is the phase shift, right? Pi over 2. Okay, now these are a pain in the butt. So let's make our 5 key points for sine. And then we'll apply our shifts. Okay, for sine, I like to use the 5 key points as 0, pi over 2, pi, 3 pi over 2, and 2 pi. And by now you guys should be so good with all your sine values. It's 0, 1, 0, negative 1, 0, if there's no shift. Okay, now here's the hard part. What's happening to all of the x's? Well, you're multiplying by 2, so the opposite of that is we need to divide by 2. But then we're also shifting it right pi over 2. So plus pi over 2. And then what are we doing to all the y's? Just a simple multiply by 3. So 3y. All right, so let's do that. So all the x's, we're dividing by 2 and adding pi over 2. So this one would just be pi over 2. This one, pi over 2 divided by 2 is pi over 4. Plus pi over 2 is 3 pi over 4. Pi over 2 plus pi over 2 is pi. 3 pi over 2 divided by 2 is 3 pi over 4. Plus pi over 2 is 5 pi over 4. And 2 pi over 2 is pi. Plus pi over 2 is 3 pi over 2. Okay, so some of that algebra can get a little tough with common denominators, but you can work that out. And then all the y's we multiply by 3. 0, 3, 0, negative 3, 0. And then you're done. There's other ways to do these, but I really think making this table just makes them all kind of the same routine. So this time, let's see, we're starting at pi over 2, and then it goes to 3 pi over 4, and then it goes to pi, and then 5 pi over 4, and then it goes to 3 pi over 2. Okay, so that's that shift. Instead of starting at 0, we're starting at pi over 2. And then the highest we go is 3, and the lowest we go is negative 3. And then, yeah, just plot your points. Pi over 2, comma 0, 3 pi over 4, comma 3, pi, comma 0, 5 pi over 4, comma negative 3, and 3 pi over 2, comma 0. And there you go. That's your beautiful sine curve that just got shifted and stretched. Awesome. Okay, moving on. Let's do a tan shift. So let's see. Let's graph tan, or let's get our 5 key points for tan without any transformations first. Now remember, what are our 5 key points for tan? We go surrounding the asymptotes at negative pi over 2 to pi over 2, which means there's a negative pi over 4, a positive pi over 4, and a 0. Those are the asymptotes, or the 5 key points for tan. And then at negative and positive pi over 2, that's where the asymptotes are. So those are the undefined values. And here, let me write down that we're just doing tan without any shifts right now. Tan of 0 is 0. At negative pi over 4, it's negative 1. At positive pi over 4, it's positive 1. Okay, now what are all the shifts? Oh, easy. Just phase shift right pi over 4. So we're just going to add pi over 4 to all the x's. Okay, negative pi over 2 plus pi over 4 is negative pi over 4. Negative pi over 4 plus pi over 4 is 0. 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is pi over 2. And pi over 2 plus pi over 4 is 3 pi over 4. Okay, and then the y's we get to keep. All right, let's sketch a graph. So we have negative pi over 4, 0, positive pi over 4, positive pi over 2, and 3 pi over 4. All right, we got asymptotes at the very left and the very right. Let's see. At 0, we're at negative 1. At pi over 4, we're at 0. And at pi over 2, we're at positive 1. And we know the general shape of tan looks something like that. Awesome. All right, moving on to number 3. So this is a cosecant. Oh my gosh, does this one look crazy? We can do it, guys. Now remember, if it's cosecant, I would start by graphing sine. Just normal. Let's just get the normal sine 5 key points down. Okay, so what are the normal 5 key points for sine? It's 0 to 2 pi, meaning we need to cross through pi over 2, and cross through 3 pi over 2. And what are the sine values there? If you go around the circle, it's 0, 1, 0, negative 1, 0. Okay, this is crazy. Notice the 1/2 was already factored out, so we do not have to do that for this one. Okay, so what's happening in the x direction? We're multiplying it by 1/2, which means we need to do the opposite, so multiply by 2. And then if we're shifting it left pi over 3, we're going to subtract pi over 3. Now in the y direction, we're multiplying by 2 and we're adding 1. But let's get our cosecant values first. And remember, cosecant is going to be the reciprocal of sine. So reciprocal of 0 is undefined asymptote. Reciprocal 1, 1, reciprocal 0, undefined asymptote, negative 1, undefined asymptote. Okay, now from cosecant, let's apply our y shifts. Multiply by 2, add 1. So multiply this guy by 2 and add 1. And when I say y, I'm talking about this one. Okay, so 2 times x minus pi over 3, so negative pi over 3. 2 times x minus pi over 3 is 2 pi over 3. 2 times pi minus pi over 3 is 5 pi over 3. And then 4 pi minus pi over 3 is 11 pi over 3. Again, that's just common denominator work. And then multiply by 2, add 1, so stays asymptote undefined. 3 stays asymptote undefined. 2 times negative 2 plus 1 is negative 1, and then stays asymptote undefined. Whew, okay, let's sketch a graph. So the x's go from negative pi over 3, then to 2 pi over 3. Oh gosh, am I missing one? I feel like I'm missing one here. Which one am I missing? This one. I skipped this one. Oh my gosh, I was writing too big. Yeah, okay. So this is 3 pi minus pi over 3 is 8 pi over 3. I was going to say, I think we're off by 1. Okay, so the next one is 5 pi over 3, then 8 pi over 3, then 11 pi over 3. All right, those are our 5 key points. Not 0 this time. We actually bypass 0. Okay, so this is the asymptote. This one's up at 3. Oh my gosh, this one's an asymptote. This one's at negative 1. And this one is the other asymptote. Okay, so again, you can see the sine curve, right? Embedded in there. But for cosecant, we want hills and valleys. So the hill becomes the valley when you flip it, and the valley becomes the hill when you flip it. Okay, so that's one period of that crazy cosecant graph. All right, and then the last one is, can you guys work backwards? If they just give you all the important information, can you write the function? Okay, so this one says it's a sine graph. So we know it's going to be y equals sine. And I'm going to leave some space in case there's any amplitude changes. Oh, here we go. Amplitude of 4 means we know we're going to have a 4 out front. Now, phase shift of pi over 3 means that in the parenthesis, it's going to be x minus pi over 3. And then the only thing missing is the period. Okay, if the period is 3 pi, then we need to figure out what that b is. And remember, to find b, it's 2 pi divided by the period. That will get you b. And if you reduce that, it's just 2/3. Okay, so the b is going to be 2/3. And that's it. That's your equation. Okay, thanks for watching, guys. That was 6.6 with all shifts imaginable. Please subscribe.